This conference will now be recorded.
Right, it starts today's session. In the last session of Python, we were discuss about data structures and its basic operations like list, set, tuple, set, dictionary, range, and its basic operations we were discussed. And today I'm going to discuss another important topic, and it's very simple topic: operators in Python programming. So what is operator actually here? First of all, operator is a symbol. Operator is a symbol which is used to perform required operations, which is used to perform required operations. For example, 4 plus 2 equal to 6. Here, plus and equal to are what actually operators. These two are operators. And here, 4 and 2 are operands. 4 and 2 are operands. So operator is a symbol which is used to perform required operations. And here 4 plus 2 equal to 6. Here two symbols are involved here. One is plus symbol for addition. One more is equal to symbol for assigning. So here plus and equal to are operators, and 4 and 2 are what? Operands, we can say that. These are. But Python supports lot of operators. First one is arithmetic operators. First one is arithmetic operators. Next one is relational operators. Relational operators. Next, assignment operators. Assignment operators. Next, logical operators. Logical operators. Next, membership operators. Membership operators. And next, identity operators. Identity operators. And finally, bitwise operators. Bitwise operators. In Python, we can work with these many operators: arithmetic, relational, assignment, logical, membership, identity, and then bitwise operators. These are all operators we have, except bitwise operators. Okay, we will use all operators in our upcoming programming. In every topic, sometimes based on conditions, we have to use these all operators compulsory, except bitwise operator, I'm saying. Why? Because bitwise operators, also I'll explain you clearly why bitwise operators, what is the use of that. But we are not going to use any bitwise operators in our upcoming session. Why? Because bitwise operators only for bit by bit calculation. In programming wise, I'll not use, but in programming wise, I'll use all these operators: arithmetic, relational, assignment, logical, membership, identity. So first, one by one, we'll look into this. Okay. So what is arithmetic operators? How to do this? These operators are used to perform arithmetic additions. That is very simple. So very simple. Plus symbol is for addition, minus symbol is for subtraction, and star symbol is for multiplication, multiplication, and slash symbol is for division, division, div, division. And then double star is there. First, let me go for modulus first. Modulus. Modulus is for, it will return reminder, modulus. And then next double star is there, that is called power. Double star means power. And double slash is there, this is called floor divide. Floor divide. These are all arithmetic operators in Python. Plus, addition, subtract, minus, minus, subtract. Star means multiplication, slash means division, modulus, and double star indicates power, and double slash indicates floor divide. We'll see how to work with these all basic operators like arithmetic operators through program. Let's flip to programming part. Let's try to find all operations quickly. It's not a big deal actually. It's very simple and straightforward things. But even I have to explain that compulsory because some students may not aware of this also. Okay, all operators like membership, identity operators. So that is compulsory, required to explain here. So 4 plus 3, 4 minus 2, 4 star 3, 4 by 2. Print, for example, here, sorry, 5 by 2 I'll take because the reason is I'll tell you what exactly. 5 by 2 means 2.5 will return. But when it comes to 5 slash 2 means it will return 2 only because floating point representation will remove. This is floor division. Print 5 modulus 2, modulus 2, and print 5 double star 2. So 4 plus 3, 7. 4 minus 2, 2. 4 into 2, 8. 5 by 2, this result is what, 2.5. And 5 double slash 2, this result is 2 only. 5 modulus 2, 2 into 2, 4. Remainder is what? 1. Modulus will return remainder. Division will return quotient. And 5 double star 2 means 5 to the power of 2. 5 is the base value, 2 is the exponent value. 5 square result is 25. These are simple. That's what I'm not writing any comment section. But look at here, 5 by 2. 2 into 2, 4. 2, 0.5, 1. That is 5. And 2 into 2, 4. And 2.5 actually, 0.5 will remove. Round up value will be there. That is floor divide. Floor means reduce. Seal means increase. Floor, it is 2.5. Floor means it will reduce and 0.5 and round up with 2 only. 5 modulus 2, 2 into 2, 4, remainder is 1. 5 double star 2, 5 to the power of 2, 5 square, 25. Same result you'll expect now, you can see. First, 7, 2, 4 into 2, 8. And 5 by 2, what actually here? 2.5. 5 floor divide 2, that is 2. Next, coming to this 5 modulus 2, remainder is 1. 5 double star 2, 5 to the power of 2, 5 square, 25. Got my point? So these are the basic arithmetic operators available in Python. Similarly, we have to discuss about relational operators also. Relational operators. What are relational operators? These relational operators are used to perform operations, and finally, based on the result, okay, based on the result, it will return true or false only. Okay, based on the result, it will return true or false. Okay, just a bit. Yeah. So relational operators all will return true or false only based on the condition. So what are the relational operators? Just observe here. Less than, it is a relational operator. Greater than is relational operator. Greater than. Less than or equal to. Less than or equal to. Greater than or equal to. Greater than or equal to. Next, equal to. This is equal to. It's not a assignment operator. Double equal to is always relational operator only. That is equal to. Just comparison. Not equal to also relational operator only. And single equal to means assignment operator. That is okay. Every time you have to say single equal to means assignment operator. Double equal to means equal to operator. That is relational operator. Actually, it is not assignment. It's a relation. Just comparing the two values and two objects in Python. And not equal to means not equal. If this will check only yes or no, like true or false. If value is greater than other number, then it is true. Less than, then it is true, like this. Less than or equal to, greater than or equal to, all are just relational operators. Great. Let's look into relational operators also quickly in the program. Print 2 less than 3. Correct. 2 less than 3, correct only. Suppose 2 less than or equal to 3. 2 less than or equal to means either it can be a less than or it can be equal to. Any one is correct. But actually 2 may not equal to 3, but 2 less than or equal to 3. Correct. So that's the reason result is true only, always. In case 2 greater than or equal to 2, greater than or equal to 3. Observe here, 2 is not a greater than or equal to 3 and even not equal to 3. Both are false. Obviously, condition is what? False. Suppose 2 equal to 3. Obviously not correct. False. 2 not equal to 3. Correct. 2 is not equal to 3. Correct. And 3 not equal to 3. Not correct. And 3 equal to 3. Correct. So these are very pretty simple and straightforward. It's not a big deal. Okay. True or false one. So these are all relational operators in Python. Now coming to the assignment operators are there. First, a simple assignment operator is this one, equal to. This is simple assignment operator, assignment or assign. Plus equals to. Add and assign, sorry. Yeah. Add and assign. First, it will add the value to the variable, and then result will be added assigned to the variable only. First, it will add one value to the variable, and result will be added finally to the variable only. Plus equals to. Minus equals to means same. Subtract and assign. Subtract and assign. Star equal to means multiply and assign. Multiply and assign. Slash equals to means divide and assign. Divide and assign. Modulus equals to same. Modulus and assign. Double star equal to power and assign. Floor divide equal to floor divide and assign. These are the operators. Assignment operators here. Equal to, plus equals to, minus equals to, star equals to, slash equals to, modulus equals to, double star equal to, double slash equals to. First, let's see this simple assignment. A equals to 5. Print A. So I'm assigning 5 value to the A variable. Assignment is over. Next, immediately when I try to do A plus equals to 2, sir. Print A. What is the meaning here? Plus equals to means what operator? I said add and assign. First 2 value will be added to already available value of A5. 2 is going to add it to 5. That is what? 7. Then later 7 will be assigned to what variable? A only. So this is the 7 result. Add and assign. First it will add the value to the existing value, and later it will assign to the new variable like A only. A plus equals to 2. This expression you can also write like this. Okay, A equals to A plus 2. Either this one or this one. Anyone you can use. A plus equals to is same. A equals to A plus 2 is same. Both are same. Result is same. Suppose A equals to A minus equals to, for example, minus equals to 2 I'm taking. Print A. So what you are expecting, tell me? A minus equals to 2 means here A value holding how much right now? 7. Whether it will be 7 minus to 5 or else 5 minus to 3, it will be there here. So generally in Python, actually, it's a dynamic interpreted programming language. Meaning is what? Line by line code will execute. So on this recent call, line number 8, A is holding what? 7. So on 7 only it will apply this logic. 7 minus 2. This minus equal to means subtract and assign. 2 subtract from A. A is holding what? 7. 7 minus 2, 5. 5 will be assigned to A only. Finally, we got this result is 5 only. Because on recent call, value will be effect. 7 minus 2, 5 only result. Okay, so like this. So right now 5 is there. So I'm trying to do A star equal to 2. Means what? 5 into 2, 10 only. So result is 10. 5 into 10, 5 into 2, 10, sorry. 5 star equal to 2 or 5 equal to 5, a star into 2 also you can, a equal to a star into 2. This expression also 5. Either you can use this one or you can use this one. Both are same. Okay. So like this, a star equals to 2 here. Suppose here a double star equals to 2. Double star equals to 2. Print what here? A. That meaning is what here? A double star equals to 2. 10 to the power of 2, that is 10 square, 100 values there here. This is 100 values or no? Yes. So a equal to 5, print a equal to a plus 2. 2 will be added to the 5, 7. 7 minus 2, 5. 5 into 2, 10. 10 double star to 10 to the power of 2, that is 10 squared, 100 only. Value is coming on. Yes. So like this, you can able to keep on apply this add and assign operator, floor divide operator. Like division operators also you can do. For example, a slash equals to 2, I'm taking 100 divided by 2. 100 is there right now, a value. Line number 17. 100 slash 2 slash equals 2 means that is 50.0 only. Suppose floor divide I'm taking. Floor divide means right now a value 50.0. Print a floor divide in the sense 25.0. But you can see 25.0 round up, it's there or not? Yes. Why? Because your existing value float value. So floor divide also will return float only here. If existing value not float value, for example, my existing value is 52. Assume that 52 divided by what we can say. So 52 is a wrong value because a is not declared any value. Let's declare that a value, a equals to 52, for example. So a double slash equals to 2. 52 by 2, how much it is? 26. Okay, 26. But 26 round up is there. For example, 53 by 2, how much it is? 26.5, like this one. But 26 only will return like this. Okay, your value, initial value integer, then float divide value is round up will be integer only. If initial value is float, then round up value will be float. For example, 53.5 I'm taking. 53.5, that is 26.0 only it is given. Because this value is float, so round up value is 26.0. So these are the floor divide, simple assignment operator. Even modulus equals to same. Modulus means, for example, a value 5, a equals to 5. A modulus equals to 2. This will return what's our remainder. Remainder is how much? 1. So these are the basic operators. There is no complex at all. Very simple and straightforward. But we are going to use in our upcoming session these all operators whenever it is required in our logical programming. So now coming to the logical operators are there and, or, not. These are the logical operators. So these logical operators also will return true or false. Yes or no. Only true or false. So look at here, it return true, sir. When it will return true? If both the conditions, are true. If both the conditions are true, then it return true. Otherwise, it return what, sir? False. Yes. AND operator is a logical operator. Finally, it return the result is true. If both the conditions are true, only result will be true. If any one of the condition is false and other case both conditions are false, false one. Let's check this. Suppose a equals to 2, b equals to 4. Print, or else directly you can apply because I don't want to make lengthy program. Okay, directly I'm taking 2 less than 3. True or not? Yes. 1 less than 2. True. 2 less than 3 is correct and 1 less than 2 is correct. Both are correct. And operator will return true because both the conditions are true. In case any one of the condition is false, 20 less than 3 I'm taking. That's not correct. But 1 less than 2, it's correct only. But even this is correct, but because of this false, obviously result is what's are false. 20 less than 3, it is not correct. 1 less than 2, it is correct, but 20 less than 3, not correct, no? So any one of the condition is false, false. Both conditions are false, false. Both conditions true only, that is true. Like 2 less than 3, true. 1 less than 2, true. Both are correct. In this case only, AND operator will return true. So return true if both the conditions are true. Else it return what? Simply false. Or I will show you or. Or will return true. When it will return true? If any one of the condition is true, or both the conditions are true. Both the conditions are true, or any one of the condition is true, or operator will return true only. Else it return what? False. In what case it return false? Both the condition false might be, that is compulsory false one, obviously false. Both the condition false means false one. So any one of the condition is true, it return true. And both the conditions are true also, it return true. But when it return false, because of both condition false, obviously false on or. Suppose here directly I'm using or. And for your kind information, or is a keyword, and is a keyword, true is a keyword, false is a keyword. These are all keywords only, sir. You can go and check out in the keyword list. There it will be clearly there. All are the keywords only. So 2 less than 3, correct. Or 1 less than 2, correct. Both are correct. Both are correct means correct only, true. Suppose here 20 less than 3, not correct. It's a false. But 20 less than 3, not correct. 1 less than 3, correct. So because of one of the condition is true, then this R will return what's a true only. In case both the conditions are false, obviously it is what? False. R. Now not is there. Not means reverse here. It return true if the condition is false. If the condition is what, sir? False. It return false. When it return false, if the condition is true only. If the condition is true, it return true. If the condition is false, it return true. If the condition is true, it return false. Reverse. Let's see this. Right now, this 20 less than 3 condition is what? False. If I say not 20 less than 3, that is what? True. Not less than 3, that is true only. Clear. So for example, here, one more, like print not true I'm taking. Not true. Not true means what? Obviously false. Even the not false means what? Obviously true it is. Line number third. So like this. Even in this case, 2 less than 3, correct. Original condition, correct, 2 less than 3. But not 2 less than 3 means what? Obviously not correct, false, opposite. Reverse order here, okay? So this is what? Logical operators clearly. Now coming to the membership operators, identity operators. Strictly remember, these two are actually new things for you, but rest of the operators already we have seen in many programming languages, basic levels. Membership operators are different, identity operators are different. Membership operators are not, sorry, in, not in. These two are membership operator in Python, in, not in. So membership operators purpose is what actually? Membership operators are used to check. Membership operators are used to check whether the values or elements, whether the values or elements are present in given sequence or not. Given sequence or not, it will check. Who will check? Membership operators will check. Membership operators are used to check. Membership operators are used to check whether the variables or values or elements are present in given sequence or not, it will check. So these are the membership operator. Membership operators are used to check whether the values or elements are present in given sequence or not. Mr. Shanmugam, can you please switch off your webcam? It will be good. Yeah, thanks. Now coming to this membership operators. So membership operators are used to check whether the values or elements present in given sequence or not. It will check. So what are the membership operators? In, not in. But these are actually keywords. In is a keyword, not is a keyword. Look at here how to check keyword list in Python. We discussed already in the basic level of programming. Import keyword is a library. Print keyword dot kw list. Import keyword. Print keyword dot what? Kw list I'm saying. Let's run this. So look at here. These are all keyword list which is available in Python. But right now we are working with operators. In that operators, so true is the keyword, and is the operator, logical operator, it's a keyword. In is a keyword, not is a keyword. Somewhere it is there not. Or is the operator. Sorry, it is a keyword. So these are all keywords what we are discussing right now. And or not, in, not in, is also keyword. You can see is keyword like this. So okay. So membership operators. So membership operators in, not in. Membership operator in will return true, sir. It will return true. When it will return true, if the value or element present in given sequence, if the value or element is present in given sequence, then in operator will return true. Otherwise it returns simply what? False. In means it return true. When it return true, if the value or element present in given sequence, else it return false. Not in will do like this. Not in also will return true. Not in will return true if the value or element not present in the sequence, if really your value is not present in the sequence, not in will return what? True only. Otherwise it return false. It return what? False. Not in will return true if the value or element not present in the sequence, else it return what? False. So let me check the practical implementation. You know already we worked with basic sequence like list, tuple, string. Okay, these are the sequence data structure we already discussed in my previous examples. No? So I'm taking one list example, just L for list. I'm taking list of values and I want to check one value 100 in my sequence or not. Simply I can say print 100 in L. Here 100 is my value or element of sequence like list, and I'm checking this 100 value is present in given sequence like L or not. So what operator I'm using? In operator I'm using here, in. So print 100 in L. So 100 in L? No, undoubtedly no, because 100 value is not present in sequence L. Suppose 10 in L? Yes, exactly. Your value 10 is there in list only, 10 in L. So like 10 in L only. Suppose 10 not in L I'm taking. Not is an operator, in also operator, not in. Not in 100, 10 is not in L? No, sir, it is available in L. But that's what it's written, what? False. Suppose 100 not in L? Yes, exactly. 100 value not present in the list only. So it returns simply correct. Your 100 value really not present in the list. So it return what? Simply correct. 100 not in list only. Not my point? Yes. Not only here. Sir, L is compulsory required? No. Directly you can take this list object into here only. No need to take any list object. So 100 not in this sequence. Sequence can be of any sequence, list sequence, tuple sequence, or string also. For example, let's take string value. Suppose my string character is X. X in DURGASOFT Durgasoft. I'm checking X value in Durgasoft string. Is there any X value in Durgasoft? No, there is no X value in Durgasoft. So obviously it written false. Suppose here S value I'm taking. S letter is present in Durgasoft or not? Yes, it is a collection Durgasoft. Somewhere it is there, S is there. So you can easily find out whether your provided element or character or value is present in given sequence or not. You can check. Sir, why we should check this? Because sometimes, given sequence, if you want to delete any values, then before deletion you have to cross verify whether your provided value is there or not. If not there, obviously you will get some exceptions like errors only. All the time your sequence of values not with you. So sometimes your sequence of values will come from database and database only storage. And first, before going to delete the record, whether that record is present in the collection or not, you have to check. After getting confirmation, then you can able to do it deletion only. This purpose we use what? Membership operators. Members means what? It's a member. S is one of the member in string only. So this is one of the member. That's what we are checking membership operators. So membership operators are in, not in. In will return true if the value or element present in given sequence, otherwise it return false. Not in will return true if the value or element really not present in the sequence, it return true, otherwise it return what? False. Simple. These are the membership operators. So we will use all these operators in our upcoming programming also. That's what I'm telling you, all basics even. So I have to give clarity. So identity operators also somewhat new in Python. Identity operators are used to check whether the variables or any Python objects are having same identity or different identity. We can check. What are the identity operators? Now we can see operators. Identity operators are used to check whether 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 the variables are any Python objects, because in Python everything is called as objects only, sir. Okay, I'll talk about this later, why everything is treated as object in Python. Identity operators are used to check whether the variables or any Python objects are having same identity or different identity. Same identity or different identity, it will check. Who will check? Identity operators will check. So what are the identity operators in Python? So these are the identity operator: is not, these two. How we have membership operators like in, not in. Same identity operators like is not are there. Is not are identity operators. So these also will return Boolean expression like true or false. So is operator will return true, sir. When it will return true? If the variables are having same identity, if the variables are having same identity, then it return true. Else it returns simply what, sir? False only. It returns simply false. If the variables or any Python objects are having same identity, both are, so it return true. Who will return true? Is operator will return true. Otherwise it return what? Simply false. So is not means same. Is not will return true. Is not will return true. Is not will return true if the variables are really really not having same identity, okay, it return true. Else it return what? Simply false. If the variables are not really having same identity, then is not will return true. Otherwise it will return false only, reverse. So let's see this is not, how it will work here. Okay, suppose a equals to 10 I'm taking. A equals to 10. B equals to 20 I'm taking. A equals to 10 and B equals to 20. Print A is B I'm saying. A is B. A is B or not? Yes. Why A is B here? Because A value and B value both are same. What are the value? 10, 10 only. A10 and B10 both are same only. So that's the reason here A value, B value both are same. Both are having same identity. That indicates that same memory address of these two variables. Let's see this, how it will be. So let's run this now. So, sorry. A is having 10, B is having 20. So that's the reason here both are having not same identity. Look at the value of the variables are simple. A value 10 is there, B value 20 is there, but both are having same. No, obviously both are not having same case. The reason is, if I say A value 10, B value 20, both are different identity. For example, I am including A value 10, B value 10. A value 10, B value 10 means, here you can see I'm drawing something so that you will be get idea. So here, this is my value of, this is 10 values there. So A is pointing 10 only. A is also pointing 10, and here B also pointing 10. So obviously this 10 is having memory address is same memory address only. Okay, memory address is same for this 10. So this A and B are having same memory location, which is going to store the value 10 only here. That's the reason here A value 10, B value 10. So identity of these two are what actually same only. So that's what A is B. Yes, A is B. A 10, B 10, both are same. So because A and B variables pointing to the same object like 10 only. So A20, B20 in the sense, suppose A20, look at here, A20, A10, A20 is there. Now you can see A is B, not correct. A is A. Let's just observe here. A is A, I'm taking. Observe here in this context, my variable names are same. Try to understand. My variable names are same, but both are pointing what? Different object or not? Yes. Here 10 is there. Here 20 is there. So A is my variable. Both are representing, this A is refer 10, this A is refer 10. Both are same. But what about these identities are now? Is this same or not? You can see values are different or not? Yes. But don't look at these variables here. Look at here, A10, B20, A is A true. Why A is A true? The reason is A and A, these both are same. Why both are same? Because A is A. Why it is true? Because A value, recent value only will be considered. A value 10, A value 20, A value 20 here. 20, 20 is 20 is 20, correct only. For example, you can see this, I'm trying to take 20 is 20, I'm taking, just clarity, you can observe here. 20 is 20. 20 is 20. True or not? Actually, this is not correct literal because we have to take a value like this. For example, here I'm taking A. Now this time you can see correct way. This is the correct way to discuss. A10, 20. Previously, don't think so like this. A value 20, A value 10 only, but A is A. Why? Because it is equal. Because recent calling only will take A value 20 only. 20 is 20, correct only. Even if I don't use this also, this is correct only. A is A. Because A value 10, this A10, this A10, both A's are there here. That is the reason I'm saying. This is true only. But consider this is B equals to 20. So I have to clarify this. A is B. 20 is 10, not correct. False. If I say 10, A is B, yes, both are same identities are because of they're having the value called 10, 10 only, A is B correct only. But what is the base? Which base through we can able to identify these both variables are having same identity? Yes, in Python, there is a built-in function available. That built-in function name is called id function. It is a built-in function in Python, sir. Id is a built-in function in Python, and id it will return a unique integer, sir. Id will return a unique integer. It will return a unique integer, and id function is used to find the memory address, memory address of the objects or variables. Anything is in Python, anything is considered as object only. Either it can be variable name or function name or class name, whatever it is, just everything is treated as object only. ID is a built-in function. It is a built-in function. It will return a unique integer, means every time the unique integer value will return this ID. So using ID through, we can able to check the identity cross verification, whether the variables are having same identity or different identity based on ID only. And it is used to find the memory address of the objects. Let's see this. Already we are working with A10, B20. I'm saying that A is B correct only. If I say A is not B, false it is, because A and B both are same, but you are saying A is not B. False. Suppose A value 20 I'm taking, A is not B. Yes, exactly. A and B not same. So A is not B. True. Because A value 10, B value 20. Sir, what basis it is going to find is important. What basis? For example, you can see what basis means. I'll tell you. Print ID of A. Look at here. When we try to print ID, it is coming inbuilt object. You can see inbuilt function. This is ID. When whatever the functions you are going to see in the IntelliSense, okay. So this is inbuilt only. So ID function is expecting what? One object. Any object you can pass. That identity will find. I am passing A is my object name. Print ID of B. So why I'm doing this ID function? Because I want to find the memory address of A and memory address of B, values 10 and 20. So both are having same identity or not, you can check out. This ID of A value is what? 175045 something 408. ID of B is what? 728 like this. Both are having same ID? No. Memory address? No. That's the reason what A is not B, I'm saying yes, A is not B correct. A and B is not correct. Even if I say A is B, false only, because A different memory address, B is different memory address. And strictly remember, every execution to execution, memory address will be changed. Now you can say identity will be changed. This is random number. Why? Because A value 10, B value 20. This ID of A, ID of B not same. For example, you can compare with like this also. Even ID of A equal to ID of B also you can do. Is that ID of A equal to ID of B? Not correct. This ID not correct. False only. That's the reason we are getting ID of A is B only. False. What happen if I take my value 10, B variable, and value also 10, A variable, value 10? So in this context, what will happen? You can see this. In this case, true is there. Here you can see true, because A value 10, B value 10, A is B correct only. ID of A is same address, memory address. ID of B is same address, memory address. The reason is just now we discussed. Here 10 is there. Here you can see 10. 10 is the value. And this 10, A is pointing this 10 only, and B also pointing this only. For A and B, both memory address will be same only. That's what ID of A value same, ID of B value same, ID of A equal to ID of B, true only. A is B also true only, because values are same. So internally, Python is having a built-in function that is called ID function. This ID function is used to find the memory address of any object in Python. Means in Python, everything is object. Later in our upcoming session, we are going to prepare some functions also. Both functions are having same identity or different identity also. We have to cross verify clearly. Okay. So this is ID function, built-in function. It will return a unique integer. It is used to find memory address of the objects clearly. So these are all identity operators, membership operators, logical operators, assignment operators, relational operators, and arithmetic operators. But we have bitwise operators also, no? Yes. But bitwise operators are used to perform bit by bit calculations on integers. Bitwise operators are used to perform bit by bit operations, bit by bit operations on integers only. Strictly remember, on integers. But in Python programming, in our upcoming session, except bitwise operators, remaining all operators I am going to include. So bitwise operators are not required for our programming, but every programmer must and should aware how bitwise operators will work. So bitwise operators are used to perform bit by bit calculations or operations on integer numbers only. And bitwise operator generally can be used in digital circuits, VLSI, MATLAB systems, and for scientific computing, faster rate of calculation point of view, we can use bitwise operators. But there are so many bitwise operators are there. First, bitwise AND is there. This is the bitwise AND symbol. Next, bitwise OR is there. This is the bitwise OR. Next, bitwise XOR is there, exclusive OR. The symbol is cap symbol. Next, bitwise NOT is there. The symbol is tilde symbol. This is negotiation, we can call it as. Next, bitwise left shift is there. Bitwise left shift. The symbol is this is. Next, bitwise right shift is there. Right shift is there. Bitwise right shift. The symbol is this is. Number of bits can move to left side, right side like this. So these we have to discuss in detail. But to work with bitwise operators in Python, you must and should aware how to convert a decimal form into binary form and binary form into decimal form back only. But in our tomorrow session, we'll discuss in detail, but just generally you can observe here in Python, converting a binary system into decimal system decimal system into binary system is very simple and straightforward. Why? Because you can take any number like a value 10 I'm taking. I want to convert this into binary form. So there is a function called what actually binary of a is there. Look at here binary of a. So binary format of 10 value, how much it is? 1010. Even you can go for manual calculation also. I will tell you clearly in tomorrow session. First topic, this is only manual calculation, how to do, how 10 will be converted into binary form like 101 value. 0b stands for binary, that you can leave it. But these two things I have to include. For example, my value is a value 20 I'm taking. Print binary of a calculation, you can directly go for a value binary of 10. So this a is different, this a is different, sir. Okay. In Python, it is interpreted language. So every time this a is different, this a is printed already. Again, this a value different. Binary of a is 10100 like this. This is 5-bit operations. We have to do this. Here 4-bit operations. We have to do this. So it will be easy. But how it came, sir? Binary of a 10 1010 means I will explain you clearly in tomorrow session. Manual calculation I will do, and this function calculation also I will show you. And how to convert that decimal form into binary form and binary form back into decimal form. Clearly, I'll explain all the bitwise operators in tomorrow session clear. And tomorrow onwards, you should join on this same link only. And this link will work 2 weeks continuously. You can join daily on this link only. Okay, after 2 weeks, and I will send a new link only. If any link is changing, then I'll update you clearly through mail only. Just wait a few minutes again.